Morning, I'm Embos. Haven't done this before. Please be gentle. Factorio 2 Space Age. Like a lot of people, the Friday Facts since the Space Age announcement has sucked me back in. Not so much to the vanilla game, it feels dull compared with what we know is coming. Instead, I've been experimenting with some of the janky expansion mods to experience some part of the future release. My main goal is to deep dive into individual mechanics. I think reading and talking about the Friday Facts is one thing, but there are additional insights that we can glean by actually experimenting. I've spent some time, found some things, and I thought I'd make a video. I'm going to show 3 designs I'm happy with, which deal with the scrap mechanic. I've got an absolute first build, a mall for expansion, and then scaling up to the start of a mega base. If you want, I could share some blueprints of these, but they are modded and obviously aren't using the space age entities, so they're going to need a redo anyway when the expansion comes out. Also, they aren't perfect, just demos, made to show the lessons I learned. The valuable stuff here are the lessons, unexpected challenges I came across, and maybe some general layouts or strategies. After that disclaimer, if anyone still wants them, let me know and I'll fix them up and save them somewhere. In case anyone doesn't know, what is scrap? First introduced in Friday Facts 399, Trash to Treasure. This one, it's the primary resource on Fulgora, which is the lightning-plagued, oil-rich archaeological trash dump. From a single resource and the new recycler building, you receive a distribution of high and low tier products, from stone, water, copper wire, all the way up through to blue circuits, low density structures, and the Fulgora specific resource holmium. Besides the oil sands, this is the only way to get resources on the planet. Well, shipments from other planets will help, but we'll get to that. So, straight away we see no uranium. So that means no local production of uranium power, fuel cells, ammo or nukes. But also, there's no coal, but there is plastic, which means grenades, military science and early capsules are out, if anyone even used the early capsules. Explosives, ruling out all tank shells, rockets, artillery, mines, and the base cliff explosive recipe. Sulfur and sulfuric acid is possible, but will be rare. Besides no local blue science, this won't be too big an issue, as blue circuits and batteries are both recovered straight from scrap. We'll only need this if there's a compelling new recipe in Space Age. I think this playthrough's rail network is 10% crushed processing units. This is the first design. I've called it the Kickstart cell. The intention of this build is to place almost immediately on landing without any high-level products and kickstart a small amount of local production. It takes in and processes from scrap, holds a buffer of every available product, and steadily cranks out a trickle of any items you need. The center of this build is these steel chests. 2 chests, each with an input, output, and a recycle feed. This is where the cell buffer is maintained and the product levels are measured. The combinators here select which item needs to be recycled. We want a method to pick from a list the highest item to just recycle that, but until Space Age, this is one of those things that is deceptively hard to do, so here's a bit of a close enough hack. I don't know how common it is, but I use a technique all the time to find the average of a list using 2 combinators. I'm sure your first thought is to find the average of a list would be count the number of unique items, combinator 1, total them all up, combinator 2, and then divide output 2 by output 1 in combinator 3, and there's your average. If you think about it though, if your first combinator counts the number of unique items here, the second combinator actually cycles through every different item and divides them each by the number of items. If you do the summation last, it doesn't need its own combinator, it happens automatically on the green wire. If I can actually work out how to add text afterwards, I think I can describe it better written down. Side note, this happens a lot in real-life industrial circuit networks. Things like averaging thermocouple arrays. It's not mathematically perfect because we're just working in integers, but it's good enough for this. I use this extensively in my custom train stop and outpost load control blueprints. Maybe I'll show those another day. The third combinator then just selects all the products that are equal to or greater than the average, discarding the rest. So why do I have 6 combinators? Well, I just run it through twice. The output of this controls the set filter on the 2 recycle inserters here. So each swing they select one of the highest count items and insert that into the recycle feed. If all that is too much, you could probably do it with a single decider. It's just something like anything greater than 50 sent to recycle, I guess. Fuck. Well, I guess that's just a lesson in diving straight into design before you sit and have a think about the problem. So, with the recyclers dealing with the highest count items, and even buffer gradually increases in the chests. Mostly it's just cycling through scrap though. Scrap takes longer to process than most other items, so I've had to extend this line here longer than I wanted for a nice compact build. It would be easy to modify this into 2 recycle lines, but I wanted to keep it all 7 tiles wide in case it ended up needing beacon stacks. The assembler at the end there can build almost anything with access to the 2 buffer chests. In fact, the odd thing about this build is it's faster at making something like roboports or modules than it is at, say, ammo. That's just a quirk of Fulgora and the scrap mechanic. It's got a potential for a speed boost, as I mentioned. It fits in a beacon stack, and there's always quality upgrades or maybe even EM plants or foundries. So, what are the pros of this build? What worked especially well? Fulgora's lightning means effective early designs need to be compact, power efficient, and resistant to brownouts. This definitely meets these 3 requirements. Look at the FFF399 again. Crafting speed 8 per second. That means it will really only need 2 recyclers per yellow belt of input. It's resistant to blockages, brownouts, mixed incorrect inputs, anything I could throw at it. There's no getting stuck if you accidentally feed it the wrong belt. It'll chew through whatever you give it. Brownouts. Earlier designs I tried involved different sushi or memory signals to decide what to recycle. If you were designing Fulgora setups yourself, definitely I can recommend cutting power to them and seeing how they behave. Anything with a circuit memory or a sushi belt to clog is going to have a bad time on Fulgora. This though, it's recalculating what to recycle every tick, so it powers up and gets straight back to it. If the chests are full of something you don't need, yes, it stops producing outputs for a while to grind down the excess, but I've never actually seen it get stuck, and technically I don't think it can. Geez, it's wasteful though. I'll come back to this. While you could just have one and swap the recipe out for what you need at the time, it's better to also stack these vertically. Adjacent setups can make anything, even feed a bus, technically, if you wanted to. I've tested out a row of these, first one making pipes, handing off to an engine cell, then to electric engines, robots frames, and bots. There are much better ways to do that though, would not recommend for this design. It is useful to have though, as it eventually buffers a stack or 2 of everything you can get from scrap. So it's really useful to have these dotted around early on, just to help with handcrafting. It is the absolute minimum setup time. This plus a few miners on a patch equals a Kickstart base. You can have this started maybe 2 minutes after landing on Fulgora. So, what are the cons? While it's quick to build, it takes a long time before it starts making anything useful. The main reason is the bottleneck here of loading products into the buffer chests. Blue inserters are faster than stacks or bulks in this case, due to them not having to wait for a full handful of whatever random item they first picked up. I tried with some legendary quality blue inserters in this bottom cell. It is improved, but still the two of them can bring in about 10 to 15 items per second, and that puts an upper limit on throughput of this design. The scrap mod has a 3-second crafting time for the scrap recipe, so it's slower than most of the other recipes. This means it's difficult to tune just how many recyclers are needed per assembler, and either the recyclers or the assembler is usually sitting idle. One reason I don't particularly trust this though is have a watch of this GIF from 399 again. We got 6 recyclers here. My guess is the scrap belt is only about a quarter used. It's blue, so maybe 10, 12 per second. So that's 2 per second per recycler. So to grind a blue belt, somewhere around 20 to 25 recyclers, or obviously less if we're using quality modules and beacons. If anyone has worked out the default crafting speed of the recycler, that would be helpful. Seems like it might be something like 0.1. So if you were designing for factory uptime, this is not great at all. Thinking about it, you're probably better off manually feeding assemblers early on from a giant buffer. I might actually end up mostly doing that early game, but I still really like the idea of plop this down on a patch, come back in 10 minutes time for a stack of robots or ammo. And if you haven't noticed it yet, the key takeaway I got from this is that having scrap flow through the buffer and the recycle line slows down the build dramatically. Uptime is increased when scrap processing is done before it hits the build. Not only is scrap half the density of unsorted products, it's also guaranteed to not be a useful product for the assembler. Watching it run, I'd guess the inserters were dealing with scrap about 2/3 of the time, so you just go and triple the throughput by pre-processing the scrap direct at patch and feeding in unsorted products instead into the Kickstart cells. Now the big one, waste. Oof. Oh, it's best not to watch this work. Its basic premise is everything that is not in the recipe that's currently selected is eventually going to get ground down to 0. While I was expecting this mechanic as a reality of the game, what I wasn't ready for was how I would feel about it. If you've ever built an enormous dedicated blue circuit factory feeding a dozen belts of green circuits and plastic, watching them pour into a machine that grinds them down. Ooh. Anyway, designs that can reduce this feeling will help for sure, especially if you want to scale at all in this game. Wasteful, oh yeah. I'd also like to add that unlike the next 2 designs, this doesn't share between storages. So the next cell down can't use the excess from this cell. Sharing buffers leads to extra complexity, but it's going to be necessary to reduce this wastage. So, what did I learn from making this? If anyone's forgotten, go back to Friday Facts 384, which is Combinators 2.0. This is a perfect use case. Space Age is going to be tuned to have new challenges for all levels of player. I often peg it wrong, but I'd guess that most players barely use circuit wires, let alone combinators. If you're watching a video mapping out mechanics of a game that isn't even out yet, congratulations, you're not most players. I propose the standard Factorio player. This is a player that deploys at most 3 circuits. 1, heavy, light oil cracking control. 2, accumulators to control backup steam power, either coal or nuclear. 3, maybe a Covarex processing setup. So that means selecting the highest value out of a mix of signals that would constantly be changing is currently outside of most people's circuit skills. And Wuber has said they aren't aiming to make SpaceX again, so this is too big of an ask for a standard player. With the selector combinator though, drop it down in its default configuration, it will pick the largest value to recycle. One combinator, done. Even with its wastefulness, this will still probably be the first thing I build. Wuber has said we can't bring our inventory with us, so when we land, we're immediately going to need to restock ammo, personal bots, and everything else we carry around without thinking. I haven't spent too much time playing with a version that also enriches for quality, but it's probably not too tricky, just not really suited for it. The janky quality mod deals with quality products as all separate items, so the buffer gets clogged pretty early. And you have to select the quality of inputs you want to use in the assembler, so it wouldn't be very automated at all. Also, just from a first look, at least at the start, quality builds are going to rely on high throughput, which isn't really part of the Kickstart cell. Seeing the downsides of the Kickstart cell, let's move on to the second design, which I'm calling the scrap mall. Okay, so bots are going to simplify the design and allow scaling well past the Kickstart cell. This one's buffer is able to be increased to this row of provider chests here. Having the buffer in a logistic network will automatically improve the last design's main drawbacks. Logistics system removes the previous bottleneck. I've got this one here working through 2 blue belts of scrap, and it could easily build in double or triple this size. Also, by having multiple assemblers sharing the same buffer for different products, this design doesn't waste nearly as much. Like I mentioned before, I've split the scrap processing and recycle loops. This helps settle out the feed coming in, and it's also easier to visually gauge utilization. Due to the greater variety of intermediates available in a bot mold, I ran the products above average algorithm I described earlier 4 times on this buffer. Mostly because using the logistic contents includes all the scrap mall output and intermediate products, which is a bit dumb. The better way to control the recycling in this build would be to wire the buffer chests together and include these recycle output chests as well. I do have a good lesson learned here actually. I originally just sent the output of the above average straight to each of the recycle feed request chests. And what did that do? Well, say there were 200 gears in the buffers. Each requester asked for 200 gears. Obviously, I didn't want to empty the buffer entirely, so I included a divide block here. I've got 10 requester chests, and I didn't want to request more than half the total buffer, so every signal is divided by 20 before it's sent out to the buffers. This actually helps in a second way that I didn't notice because it's an integer division. If the buffer has less than 20, it wouldn't get requested. If only I'd thought of that part first. Okay, so we've got the bank of recyclers requesting and feeding through to the logistic network. Because of the mod, which has crude barrels and uranium instead of ice and holmium, I had to change it up a bit, running uranium processing, Covarex, and oil processing here. Don't worry too much about it. Passive providers for the first buffer chests. Active providers on the recycle chests. You want products getting used from here first, otherwise byproduct backups are going to occur. After that is just laying out assemblers for the beginnings of a standard bot mall. I left room for beacons, but they really aren't necessary. A bot mall will always just build up the requested amount of products, then usually sit idle anyway. Lastly, because I wasn't actually rolling out base, I just put a little artificial drain on the bot mall. All the products that are being made are requested by this chest down here, which just voids them. This solves all the weaknesses of the Kickstart cell, which were speed, uptime, and wastage. It's much more flexible as new items are needed. Adding, changing recipes are easy. You can add temporary assemblers, vary quality levels, etc. Back to uptime, this is the first design I'd consider putting serious resources into because it's not worth spending much on the Kickstart cells if they are just going to sit there churning away, not producing anything. The payback of this one will be much quicker. The big downside for this are the expected bot mall downsides. It uses a lot more power for the same production, especially with beacons, but even without. While I haven't been deep diving Fulgora, just the scrap mechanic, I think power is actually going to be a sleeper challenge here. The main reason isn't the lightning, the reduction in solar, or the water limitation. It's actually going to be the islands segmenting our power grid. From Friday Facts 399 again, islands are usually separated by a gap that's larger than basic quality big electric poles. Looking at the map generation, it looks like you will probably struggle to link more than 5 or 6 islands together, which means we are going to need to carefully manage where we are generating, storing, and using our power. We'll work it out when the expansion's in our hands, but at this stage I'm planning to include in my train design a small nuclear steam supply train, as this beats any current game system for energy density. Cut down to the next section, the small islands are always isolated by a moat. I'm reading that to mean greater than the distance of a legendary power pole. The special significance part, whatever that means, definitely means we won't want to avoid them, so these will need to be either self-supporting or have power trained in. Unrelated, I'm also guessing that moat distance will also conveniently be greater than logistic network size, so no chance to just extend a network over to the small islands. I am looking forward to it though. Up till now, this hasn't been a puzzle we've had to solve before. Power distribution has always been cheap and simple. It's another thing I'm really looking forward to. I did just see Friday Facts 420 fusion reactor, which if you haven't checked out is going to be an easy 10 to 20 times output of a nuclear setup today. And more importantly, it doesn't consume huge amounts of water. While it will certainly be helpful to build a massive bot mall, I think it will be overkill, as you will have this gigawatt scale power production that you can't extend to more than a few islands. The other downside I discovered, I'm actually going to roll into this build's key insight. Throughput is still lower than I'd like, especially for the lower tier items like belts, rails, medium power poles, things you need at scale to build a decent factory. And you probably don't want to wait for a home planet delivery for, unless you are more organized than me and arrived with all of these networks set up already. Congratulations, now piss off. So, I've been working on a method to improve this. It's not anything new, but I'm calling it spiking for this video, for now anyway. Okay, what is spiking? In chemical industries, spiking a process means adding a small amount of something with specific qualities to change the properties of the resultant output. Let's assume you're like me and you arrive on Fulgora without enough rails, belts, poles, miners, whatever. Instead of having to set up multiple Kickstart cells and grind down everything you get for plates to make belts, a small import of plates into the system will have a huge effect on overall throughput. Watch this example. 70 bots to 150-ish just from adding iron. So I'm going to be loose here and use bot utilization as a rough guess that throughput doubled. This is conservative because adding lower tier items actually reduces the recycling duty required, so more trips will be supplying the mall. So it's somewhere north of double, but I'm not going to build a test setup just for this. Double works for me. So just from adding about 30 per second of plates, that's stack inserter box to box here, I'm processing 2 blue belts of scrap, which is 90 per second. I don't want to generalize here, but for a base like this, if you added a belt of iron plates for every 3 belts of scrap, you will double the throughput. This isn't even the max. If you were to tune it, you'd gradually increase the amount while watching the logistic network. When you see the recyclers requesting iron plates, that's past the sweet spot. Dial it back about 10%. So, how do you choose what products to spike? There's no universal solution, but this scrap mall heavily skews towards iron demand. That's for 2 reasons. Demand side, this mall is geared towards factory buildings, inserters, rails, assemblers, etc. It's common knowledge that a construction mall uses more iron to copper. Looking at it now, I see I've forgotten belts minus chem plants. Doesn't matter, we're already starved for iron, we're struggling to make rails at the moment. On the supply side, the key difference here is the LDS. The mall doesn't use it for anything. Low density structures is only used for personal equipment, yellow science, and rockets. And recycling it provides more than enough copper and plastic for our needs. So if we were to start launching rockets direct from this mall, which we could, this would change, and we might need to spike in copper too. Or maybe if there was a need for a large-scale solar or nuclear builds on Fulgora, but I don't really think that's likely. So here's my last design for today. I think this is the sort of thing that would be needed to scale to late game. I knew a train base was likely going to be the end result, and I have played with LTN before, but I haven't delved too deep into the complex overhaul mods with all the byproduct management that comes with them. So I've never built this sort of base before at this kind of scale. I was still able to use a previous many-to-many train network from vanilla with almost no modifications though, and I was able to get it working easier than I thought. The first section is the unsorted supply. It's deliberately outside the block and outside the design because the intention here is to move this local to the scrap patch. I had some earlier designs which started with train deliveries of scrap, but just this setup here needed 12 blue belts of ore. That's one of my little 1-4 trains every 15 seconds. For this design, it ends up being about 80% of the overall train deliveries, and I reckon that ratio will probably hold as you scaled up from here. This is about the minimum size for an effective train base. You're definitely going to want to multiply this, but at that point you're going to need to worry about train throughput, at least at your problem junctions. This has helped somewhat with the simple process at patch philosophy, which at least halves the number of supply trains. I'll talk later about some extra improvements that I'll be using for the next builds, but just imagine this section being a standard train drop-off delivering 6 belts of processed scrap to be sorted. Part 2, sorting. Some way or another, you're going to need to sort the individual products for buffering in trains and delivering to end users. I didn't put a lot of effort into compressing it. It's mainly laid out like this for visibility, using a pretty standard 2-belt bus feed with filtered splitters. You might want to group similar products together, e.g. red and blue circuits, or to peel off locally used stuff first. What I think is important is to peel off the higher percentage stuff first, letting you collapse down to a smaller sorting array much quicker. So using the rough details from the FFF, I'll bring it up again here. The first thing to peel off is iron gears. 12% shown here, and the values add up to only 48%. So that means a full quarter of your unsorted scrap is going to be iron gears. While technically that means a design like this could support 8 belts of unsorted scrap with 2 belts out of gears, you'll definitely want to have a safety margin here. If at any point the gear output belt is full, the whole system backs up and you're sorting nothing. After gears, you want all the other 5 to 7% products, so that's stone, concrete, solid fuel, and not in the scrap mod, ice. After those, you can safely collapse the belts down and filter out the 1 to 3%ers. For a reason I'm going to mention at the end of the build, my actual Fulgora splitting is not going to look like this. It will be larger for one, but the product mixes coming in here will be different and overall will be much simpler. Okay, now time for the real build. This is the first build in this video that separates before buffering products. I've gone with 6 chests per wagon, meaning we hold a buffer of 8 train loads for each product. Normally I'd filter out all but maybe the first row on each chest to prevent overbuffering, but for Fulgora, more buffering means less wastage, and less wastage means higher overall throughput builds. These train stations are a previous blueprint book I made for many small manufacturing blocks. They've got minimal logic. There's, I think, 2 combinators plus a constant, so I guess 3 combinators, and it abuses on-wire distributed calculation to do all of the following. They provide buffer details to a dashboard, which updates automatically on addition or removal of stations. They decide themselves which station should respond to a request, factoring in distance and buffer levels to auto-balance across stations. They prevent contamination. They only release trains with the correct material. All of this was out of the box, but I did have to frig in an additional requirement. If a buffer is more than 90% full, I wanted it to ignore the rest of the logic and go dump a train load at a recycling station and return. While I'm super proud of how it works, it isn't really the purpose of this video, and come space age, everyone will be doing this via train groups and interrupts. The dashboard here is almost my vanilla science materials dashboard. I've just added a few extra products in the spare slots. I can honestly say I've never monitored a buffer of copper wire before. It doesn't do anything except display all the values on the green circuit network. There's really no central brain to this at all. It's all in the stations. So every product in the network needs a location to receive a train load from a full station. But thinking about the products, they don't all need to be unique stations. The product being recycled will either make new useful products or they won't. This is my favorite station. This setup can deal with red or blue circuits or low density structures, as their outputs are actually very similar. This guy is overbuilt for the setup I've got. None of these products need to deal with any more than a single belt, but ideally this setup would only be needed once and you could have multiple distributed sorting setups. Here's a overall map view showing the whole design. The one in the middle doesn't actually output any products, it just loops the recycled outputs back on itself until there is nothing left. This is for the products that don't recycle into anything useful, like plates, solid fuel, or stone. The one on the left I should probably zoom in for. This one deals with overflows of gears and concrete and supplies stone bricks and plate. And for a Fulgora train base, that's it. Pros. As you'd expect, This was designed to deal with the scrap mole's weaknesses. So a design like this performs better for scale, upper limits, wastage, and energy efficiency. Scale. Train throughput currently dwarfs all other logistic methods in this game and is almost mandatory for building at any real megabase scale. I'm not going to change anyone's mind here. You either already use and love trains or you don't, but I believe you will struggle to build any bigger than this without them, and this is probably the smallest train base you can build, unless you shrink the trains down to tiny 1x1s or 2s. For energy efficiency, there's no bots required here and nothing but recyclers. It would be no problem at all to remove the modules and beacons at the start. I was just using them because it's creative mode and just for show. Like the bot mall, spiking in plates and green circuits would be as simple as connecting new supply stations from the landing pad. Rail and circuit connection, and they will feed into the existing network, no problems. While this is the best design I've got to show at this point, every design has its own downsides. Obviously, using train networks and stations takes much more space. You can see I built this into separate components to try and mitigate this. These are intended to be put on separate islands, but you'd still need to claim a few islands for this base. This is pretty much the smallest you could make it, but is also built to easily scale up from here. You could compress it down to 2 blocks, 1 sorting station and 1 recycling station, but I built this for visibility, so I split it into 3. The one thing missing from this demo build, there's not actually even a connected factory. It's beautiful to watch, but this makes nothing. I didn't build anything because the next thing to build is just a block or 2 of production, maybe a mall, science, but there's really nothing different or new to show there. I guess the downside I'm trying to show is this is the level of infrastructure you need to build before you can start on any actual contributing part of the base. You can't easily make this from scratch without supplies and construction bots either. This is what the Kickstart and then the scrap mall are better for. Both of those are within easy handcraft size. Complexity. In addition to setup resources and time, there's also the required circuit knowledge to build this or something like it. Again, most people play, and standard Factorio player, 3 or less circuits. While technically you could take this blueprint and use as is, it probably won't work exactly as you expect, and it won't work as well for you as you expect. You will get consequences like train deadlocks or sorting jam, and without understanding the underlying design, you won't be able to troubleshoot. I wasn't going to talk about it here. I've already covered this network's functional design. I spoke about its requirements, and while it works well for vanilla, this system had the extra requirement foisted on that a station sitting full was not allowed. Obviously, vanilla Factorio, a station sitting with a full buffer, no immediate problem. Go increase science production. So to deal with scrap processing, I decided to hack a priority override in for a full station. This actually ended up breaking the original train network design. Auto-balancing between multiple suppliers will no longer work. If I had 2 of these stations working, I don't think it would work forever without gear wheels running dry in the close one and backing up further away. This would stop the whole sorter, so obviously not ideal. I'm not planning to update this until the release though. It works perfectly well for vanilla, and I want my next build to fully use the new train interrupts and station priority features. So what's the main thing that I learned? Don't transport scrap. The scrap mall design made it clear that buffering scrap leads to about 2/3 wasted throughput, but this message is even more pressing. If you transport raw scrap on trains, 4 out of 5 of the train journeys on your network are moving scrap. That can be slashed in half at least by instead carrying raw unsorted ores. Scrap to unsorted compression is 2 to 1 for belt transport, but when you consider stack sizes, the ratio only gets better. The scrap mod uses oil barrels instead of ice, which we don't know the stack size of, but I'm going to guess 50. And there's LDS, which definitely hurts the ratio, but with a bit of cleverness with train loading, you can concentrate the 100 or 200 stack size items into specific wagons. The batteries and copper wire you get from a 1/4 train load of scrap, 1 stack each. Not much worse for red and blue circuits and steel. It's less than 2 stacks per train load. There's ways to improve it further as well. If you wanted, you could peel off some of the ice and solid fuel at patch for local power production. Solid fuel is probably the most worthless item of the unsorted scrap. Stack size is 50 and it's available anywhere for free with the oil sands. Once you have plenty of stockpiled steam, you could even go as far as converting at patch to rocket fuel. Ignoring any productivity gains, 100 water turns 2 stacks of solid fuel into 1 stack of rocket fuel, some of which can locally feed the trains. Solid fuel has no other use and all its products are available, so call 100 water a stack of ice and you found another 3 to 1 compression with no downsides. I'm a little worried about the scarcity of water, but really its main uses are going to be power generation and cracking to help make rocket fuel, so you may as well do it on patch. We might get lucky in space age with a new use for low density structures, but at the moment we can't really do the same with LDS yet. It's only used in personal equipment, the rocket and yellow science, so nothing really worth producing at patch. Maybe at patch, depending on your usage, you might want to smelt some of the stone into bricks, walls, or maybe even landfill. It's up to you. Me, personally, I think early on the main stone user will be rails, overheads and such, so I don't think it will be helpful early, but could potentially be an efficiency boost once you've mostly laid out your rail network. So, process at patch, strip off some of the low value before going onto trains, including your mining outpost, some local steam power, and rocket fuel generation. I finished this one up to showcase, otherwise I'd never actually finish. But even while making it, I've come up with some pretty major improvements on this design, hugely reducing unnecessary train traffic and reducing overhandling, overbuffering. Because I just use my pre-existing stations, the logic isn't really perfect for byproduct management. At this point, this station can really only deal with a single sorting hub, so that puts a fundamental size limit on the base to not much bigger than what you see here, dealing with more than, say, 20 scrap belts. Of course, there are upgraded green belts and belt stacking to push that cap out to maybe 10 times what you see, but I'm expecting to head to Fulgora first, and I believe both of those won't be available until after Volcanus. Also, I think most people are probably underestimating the recipe cost for these high-tier items. The price already goes up by a factor of 5 to 10 per tier of belt, so here's my prediction. 1 green belt is going to cost about 200 raw ores and require blue belts, but also tungsten and 1 more fluid. That means a base this size can't afford to upgrade sorting by this much. It would be much more cost effective to improve the logic to allow for distributed sorting and build 5 smaller ones of these. The final design is just in my notebook at this point. I haven't tested it out yet. I still might, even just to show the philosophy in a follow-up video. Well, that's about it, but I should probably collect the ramblings into some thought-out closing comments. I didn't mention it in any of the builds, but rockets from here are going to be especially easy, almost directly from scrap. I'm expecting to export from here for high-tier circuits, legendary items and modules. So I don't know about you, but it seems like this is the smart first stop after Novus. Probably. Really don't know that, but if you want the legendary personal gear and platform equipment, beeline here. Back to the builds. First design priority always has to be backup prevention. The space age expansion leans into multi-surface, so you aren't going to be around to babysit, clear blockages, or prime blueprints or combinators with initial states. It has to be able to run direct from placement by bots, never get stuck, and if it does clog, be able to work through it without intervention. Those two insights I'd figured out going in though, and I'm sure you guys had too. Here's what I've learned while working through these 3 builds. On Fulgora, buffers are your friend. They reduce blockages when byproducts back up, and linking buffers together minimize wastage, which maximizes throughput per scrap mined. Like regular Factorio though, if you are limited to a single sorting or handling location, then you've just put an upper limit on the throughput of your base. So the perfect Fulgora mega base is going to have many distributed modular buffers, but still somehow coordinated to minimize wastage. Brush up on your global local variables, work out what a buffering outpost needs to communicate, and how to determine where to supply your base from to auto balance. Don't transport or handle scrap. That's the space age equivalent to putting a copper wire on the bus. If your base has to process scrap with the same machines doing the recycling loop, see Kickstart 1, then you have reduced throughput by somewhere around 2/3. Separate the 2 stages of recycling, keep scrap processing local to patch, and just transport the unsorted products. Side note, train efficiency is improved by stripping out low-value products as early as you can. At the moment, this mainly applies to solid fuel. Strip and process to power and rocket fuel would be worth a small blueprint for every mining outpost. Lastly, assist scrap malls by spiking them with imported plates from off-world. I haven't really got hard numbers for this, but I noticed that importing plates reduce the amount of recycle loops to get the needed recipe items, especially for base building. It doesn't take much plate to get a noticeable difference in scrap mall productivity. You could consider also importing a trickle of green circuits and plastic if you want, but plastic is really only used for red circuits and low density structures, so you shouldn't need much at all. Your whole base uses green circuits though. That's probably product number 3. Think about the benefits, especially when you consider this is almost zero cost. You have to set up this transport link anyway to bring back all those legendary modules and blue circuits, so why not ship up a few stacks of plates and green circuits? Side note to this, do not assemble things that come from scrap. If you somehow have too many plates and green circuits from off-world and decide to plop down an assembler for low-density structures or advanced circuits, stop. Think about the choices you have made that have led you here and add more scrap processing. It might seem harmless, but setting up Fulgora, or any planet really, to be reliant on off-world deliveries for its production chain is a bad idea. Keep it as modular and self-sufficient as possible. I'm pretty sure Aquila's mechanic is going to force an interconnected chain anyway, but we'll cross that bridge when we come to it. Thanks for listening to me ramble. I do want to know what you think about improving these designs. My plan is to beeline to Fulgora already knowing exactly what I'm going to build and how I'm going to exploit this mechanic. I might look at some other mechanics in depth. Really, I'm just looking for ways to explore the design space of my favourite game and kill time by prepping some blueprints instead of downloading Pyanodons. Thank you.